Yeah, and sorry, I missed who asked the question, as well as the title of the original book. I think something was mentioned before First Steps there, but if you want to drop that in the chat, we can maybe circle around and answer your question afterwards or through email. But to get us started here, first of all, just welcome. Just make sure everybody's in the right spot here. We are looking at the fourth of 5 in our series here. And my name is Chris Hunter. I'm a helping teacher in Surrey, supporting teachers K through 12. But I'm joining you here today as the Vice President of the BC AMT. And joining me is Sue Robinson as well. And prior to getting into the content of this workshop here, we just wanted to take a moment here to acknowledge. We could just hit play here. So like I said, I'm joining you from Surrey. This is on my, this is a public piece of art that is on my commute to work every day that I drive by, Bear Creek Park in Surrey. So that may be familiar with the area. Anyway, I would like to acknowledge that I work and learn on the unceded shared territories of the Coast Salish. Specifically, I acknowledge the Katzie, Semiahmoo, and Kwantlen First Nations who have been stewards of this land since time immemorial.
Hi, I'm Susan Robinson. I am speaking to you from Salt Spring Island. This is a photo of the view from Churchill Beach, which is one of the many places that I go swimming around the island. I'd like to acknowledge that I live, work, and play on the traditional unceded territory of the Coast Salish people, specifically the Halkomelem and Tsimshian speaking people. So welcome everyone. As Chris said, this is the 4th of 5 sessions. We'll be looking at 3 routines in particular this afternoon: Would You Rather, Clothesline Math, and Always, Sometimes, Never. But before we get into those 3 routines, which really focus on justifying choice, we're just gonna, we always like to start with a little bit of math talk. And so we're gonna jump into a routine that Mark Arnault spoke about in his in the last presentation, probably about a month ago now, what's the same and what's different. So we've got 2 images here on the screen, and the question is, before I throw the question out, I'd like to just go over a protocol. Eventually, we would like you to type into the chat some of your thinking about what's the same and what's different, but if you could hold off on typing right away, and so that we just give everybody think time. So in my classroom, I would ask my students to have a look at these images, think about what they see as being the same, what they see as being different, but to really encourage them to think quietly on their own before they share anything. Because we're not going to be able to turn and talk to the person next to us after I've given you, and it will probably be a short think time because we're only here together until 4:30. Then when I give you the go ahead, start typing into the chat and we can share that way. But right now, we've got these 2 images. What's the same? What's different? And wait time as we are sitting here on Zoom is feeling really awkward. So hopefully you've had a chance to do a little bit of thinking, throw some stuff into the chat. And then if anyone, we're a pretty small group here. We're just under 30. So if anyone wants to unmute themselves and talk about what they see and what's the same and what's different, that'd be great. So we've got same size whole divided into equal parts, but we've got halves and quarters. Same part over 1, both broken into powers of 2s, halves, quarters, different color. Both are unit fractions. Or wait, no, fractions divided into equal parts. The yellow is half of the blue. Anything else? So I use same different in my class all the time. I teach grades 9 and grade 12. We've got a couple of other examples of these same difference. So here's one, if you want to talk a little bit about fractions. Here's another one about fractions. I really like this one because it shows 2 different strategies for comparing fractions. So often my students will have one strategy. They're very quick to talk about looking at fractions with common denominators, but they don't often think about comparing numerators and finding common numerators. And so this image could get them talking a little bit about the different strategies and what might be advantages to either of this strategy. I use this a lot in my upper secondary classes, so calculus and pre-calculus. So this is an example of a question that I gave my calculus class last quarter. And this was it. This was the question. So really, I'm able to pare down the question and give the students some freedom about what it is that they're going to talk about. Although there is a shared understanding that really I want them to be looking at features of these functions, hoping that they're going to start looking at the components of the equations and how by changing this power of 3 to a power of 1/3, it can radically alter the look of the graph and what's happening at different points on the function. And so I like that it's not me just saying, hey, here's a list of things I want you to tell me about, but giving the students that flexibility. And I'm always hoping that they're going to notice something that I hadn't thought about and bring something new to the discussion. If you want to learn a little bit more about alike and different, Chris has actually written an article about this that appeared in Vector in 2018. We're hoping that eventually we're going to make these presentations, the slides available on the BCMT website. Maybe while Chris is talking, I will do a little bit of work at putting this link to the Vector website into the chat box so that you could easily go find his article if you like.
Okay, so we just wanted to take take a moment here to discuss the why, the reasoning behind using instructional routines in your classroom. Specifically focusing on the routine part of it. I know that Sue is going to talk about some of the other benefits later on, specific to some of the routines that we're sharing today. But just this idea of an instructional routine and what that gives, provides us, how it supports us as teachers as well as our students. So taken from this resource here, Routines for Reasoning by Grace Kelmanic, Amy Lucenta, and Susan Creighton. Okay. So the key part here with a routine is its predictability, right? So we have routines perhaps in our classroom for other non-instructional purposes, for handing in homework, for getting in and out of the classroom and so on, for forming groups. This is looking at an instructional routine here though, right? So have a routine that's related to learning, right? And so the benefit of that predictability for both teachers and students is that we're able to pay more attention to the student thinking, right? So as a teacher, you're as a student, you're not having to think about what does the teacher want me to do next? What are we supposed to be doing? That type of thing. there's a well-established routine, so you can really just focus on the mathematics at hand here. And similarly then for the teacher, same idea here is that we can really attend to the ideas that our students are sharing, rather than what is our next teacher move here? How do we keep facilitating this task, right? So as we become more familiar with the task and that structure, then we can, again, it frees us up to better pay attention to the student thinking. So as Sue and I both mentioned, this is the 4th of 5 series on instructional routines. So prior to Sue sharing the first one, Would You Rather, we just wanted to take a moment or two to have you share and maybe to look back on the first 3 sessions, if you've attended any of those first 3. And even if you haven't, perhaps you have some experiences with instructional routines in your own classroom. So Sue, we never did, I don't think, because we were going to kind of make that call in the moment here, decide whether we were going to do a breakout room or if we just wanted to leave it for the chat or have people unmute themselves. So I am fine with however we want to do this.
I think breakout rooms are good because then you can have a small conversation and then we'll bring everyone back after. It's probably going to be fairly short.
Yes, yeah, I would say 3 minutes is probably good there. And I believe that you have to do that.
Okay, so I will assign breakout rooms.
Okay.
You may want to pause the recording before you do.
Oh, okay, yes.
Before you launch them.
Thanks, Mark.
So there are, I'm going to make 6 breakout rooms. I'm going to pause the recording.
Okay.
Somebody was asking in my breakout room about the instructional routine cards that the BC Numeracy Network have made. We've got a set of cards. I don't have any at hand in my classroom, but if anyone's interested in the instructional routine cards, I'm going to put in the chat my email address. You just need to email me and I'll talk you through what you need to do.
Sorry, I've lost the ability to see the chat to keep one eye on what was going on here. So for some reason, I'm not getting like the pull down menu anymore.
Oh,
when I started sharing, and I had it earlier. But so if you're wondering why I keep redoing the slide, that's why.
Okay.
But why isn't it? So I do have.
You're still host, right?
Yeah, sorry. Oops, maybe I gotta do. Sorry, give me a sec here. I'll just share the screen again. Let's try this one more time. There we go. I think I got it back now. So let's try. There we go. How's that? You're up.
Okay. So our first routine is going to be something that is called Would You Rather? And typically there might be a choice between 2 things. I'm going to give you a choice between 3 things. And I want to credit Chris for this particular Would You Rather example. It's something that he did with a group of teachers at a leadership summit many years ago. And I use it in my Math 9 class all the time. It always generates some good discussion with my students. And so would you rather, so let me go through the protocol again. So in my classroom, when I'm doing these instructional routines, I will introduce the routine. I only use a few routines with my students, so that is easier for them to keep track of what to do. But the protocol is the same regardless of what routine it is. I'm going to put something up on the whiteboard. It might be a question, it might be a picture, it might be 4 images and they have to pick between things. And I explain the task, and then I say, I want you to think quietly to yourself. And once you have made a choice and you have a reason for your choice, just show me by holding your thumb up close to your chest. If you're waiting for other people to finish, can you think of another way to justify that choice, or can you think of a reason why the other option might be a better one? And just to keep people from putting their hands up, we actually had a nice conversation in my Math 9 class today about what that does to the thinking in a group of people, and how if one student is quick to put their hand up, then the rest of the students are given permission to stop thinking, because they can see that the person who's put their hand up already has an answer, so why bother doing anything else? And so then I have them think quietly, and then I ask them to turn to the person closest to them and have a conversation. Or maybe at the moment I have students sitting at table groups, and they're so maybe they'll talk with 2 or 3 other people and just share their thinking with one another. And then we'll have a few minutes where we'll have an open conversation with the whole class sharing their thinking. Sometimes I want to see and hear what every one of my students is thinking. And so sometimes I will make sure that there's a sticky note on everybody's table before we start the activity, and ask that in their think time that they jot down something, so that I can then collect them and have a look later on. So actually right now I have, we did a would you rather today. I have all my sticky notes, and I need to have a look at them this afternoon later on, just to see where each of those kids were thinking. So would you rather 12 cans of Coke for $4.50, 20 cans of Coke for $6, or 24 cans of Pepsi for $7? So again, I would give people wait time, but because it's very awkward to just sit here on Zoom waiting for you all to do some thinking, if you would like, you can start throwing things into the chat. So the idea here is you're going to make a choice. You've got to make a choice. You can only purchase one of these arrangements of pop. What choice are you going to make? And what's your justification? And feel free to throw things into the chat. Oh, Chris, that's interesting. I haven't had any of my students ever take on that perspective of being the seller of the Coke or Pepsi. I did this in my class last week, and we had an interesting conversation about what the students' mothers would say if they showed up coming off the bus with a 24 case of any kind of pop. And so we actually decided that the 20 cans might be more reasonable than the 24, only if the students had some friends coming home with them. Okay, so now we've got some people comparing the prices and looking for unit prices. So we got
and also,
oh,
I was just going to add here, just to notice that unit prices is certainly one direction that we can go. Either how many dollars or cents in this case per can, or how many cans per dollar is another way to look at it. But I think Mark and perhaps one other person there noticed that that was kind of unnecessary just to compare 12 and 24. So some different strategies here will emerge as well. Just by doubling, we don't need to get into any calculations of 450 divided by 12 and that sort of thing. We can just do a doubling and rule off the 12 cans if we're looking for the cheapest unit price there right off the bat.
I had one student this week or last week when we looked at this in class, he decided he wanted to compare how much it would cost for 4 cans.
Right.
And so saw that he could do that.
Wow, that's, yeah. I've seen it go the other way. So 4 there is a common factor of each one of those. I've seen it go the other way as well. So a common multiple for 12, 20, and 24. That's a little challenging. I think it's 120. But with smaller numbers, or even with 12 and 24, we have that common multiple of 24. But we could use, say, 12 and 20 and look at 60 cans. There's another way to go as well.
We've also in my class looked at how many cans of Coke or Pepsi we could get for $42.
Right.
Although we did that after eliminating the 12 cans of Coke for $4.50 as a possibility.
Okay.
And so today we did a would you rather in my class today, and we talked about the difference between a mathematical reason and a non-mathematical reason. And so the kids started by really looking at some of these non-mathematical reasons. And when I threw out, well, what would be some mathematical reasons? That's when they started to do some math. And so sometimes they need to be encouraged to do that. One of the reasons we really love all of these instructional routines is it gives us a chance to focus on the curricular competencies in our classes. And in particular, for these routines that we're introducing today, which really focus on making a choice and justifying it, it really hits this communicating and representing competency where students are asked to explain and justify mathematical ideas and decisions. So that first part is common to all grades K to 12. In many ways is a piece that's been added on for 10 to 12. And so this idea of explain and justifying, making use of mathematical arguments. So moving kids away from making a personal choice. Well, I like Coke better than Pepsi or Pepsi versus Coke, to then coming up with, well, let's look at some of the mathematical reasons why one choice might be better than the other. And in that first example, the unit price between the 20 cans of Coke and the 24 cans of Pepsi were so close that maybe that personal choice was then going to be the deciding factor. And so then as we move through the 10 to 12, not only do they want to come up with mathematical arguments, but they want to start to be able to convince other people that their arguments are sound. We want them to be making these decisions and being able to defend their choice and to be able to do this in many ways. And so certainly the oral factor of these instructional routines gives kids a real chance to talk about their thinking, to compare what they're thinking with other people, to hear what other students are looking at and how they're looking at making these decisions, and just really moving away from the idea that all math has to be done on paper and in worksheets. One other curricular competency that I didn't mention in that particular slide that is specific to grades 10 to 12 is that they are expected to take risks when offering ideas in classroom discourse. And so these instructional routines give kids a chance to, take part in the conversations. And so I had lots of kids today debating, whether a cherry pie would be better than an apple pie. But then helped them move into the idea of some mathematical thinking. So just a few quick examples. I can't speak too much longer on would you rather, because I want Chris to have some time to talk about Clothesline and the other routine, always, sometimes, never. And so here's another example. Would you rather have $225 or a stack of quarters as tall as you? This might be a question where kids could quickly use personal preference as their decision-making strategy here. But then when we start to think about it, we also need to point out, well, with that particular question, you don't necessarily have all the information you need to know. And so we can start to think about, well, what is it that we know? What do we need to know? And how are we going to find that information? So that students start to think about, well, how do I know if a stack of quarters would be better than $225? What is it that I need to do to find this information? We've got another few examples here. Would You Rather Math is a website where you can find lots of these visual images with these would you rather questions. And this is the task that I did in my class today. And we ended up talking about fractions for, I don't know, a good half hour, looking at different ways that we could make the decision about how much of the pie we would get in either of these scenarios and which would be better. So I don't know if you're familiar with this book, Becoming the Math Teacher You Wish You'd Had. Anytime somebody asks me for a recommendation, this is my #1 recommendation at the moment. And I really love this book because Tracy Zager, the author, focuses on what mathematicians do. And she's put together a list of these things, these habits that mathematicians have. And each chapter is divided into looking at in depth, what does it look like to make mistakes? What does it look like to be precise? And so if we want students to become mathematicians themselves, we need to give them opportunities to engage in mathematics in a doing kind of way.
Okay, so I'm going to introduce our second kind of new routine today, which is Clothesline Math. And this is a photo from one of my colleagues' classrooms, Alex Sable, also a member of the BC AMT executive here. So the idea with this routine is that you have a physical clothesline, an actual physical number line at the front of the room. So I usually just go to the dollar store, pick up a thing of twine, as well as some magnets or what have you, and create this number line across the front of the room. As well, we have little cards that in a moment you're going to get a chance to kind of experience that. And the idea is that students would come up and place and space. I'll talk a little bit more about the difference between those two verbs, place and space, in a moment. We actually place it on behalf of their group at the front of the room here. So one of the things we just to keep in mind is that we kind of treat this one as the master clothesline at the front of the room. But what I want students to be able to do is that they also have their own clothesline at their desk, usually in groups of 3, and usually it's on a whiteboard where they just sketch out a line and then sketch out where those numbers might be. The person who would be at the front here, it's often kind of difficult when you're standing right on top of your work to see if you've placed it correctly. So that person is kind of the volunteer for their group, and they'll check over their shoulder and see if their partners will give them the thumbs up, or they'll tell them, move it this way, move it that way. Yep, looks good, that kind of thing. So they rely on each other that way. So the routine part of it then is that students will be given a set of cards, a set of cards is displayed at the front of the room. Okay, now in this case here, I've used 6 different cards. I've found through experience after a while here that this is probably a bit much. I now try to look at, say, 3 to 4 is probably sufficient to have a discussion about the relationships between these numbers. And notice also that I've purposely put them in the wrong order. Sometimes you'll get kids come in, they'll see this and they'll want to immediately start fixing it right off the bat. Like it's just something it's wrong. I can't, there's some tension there that they want to kind of, you kind of hook them right off the bat with that. Okay, so with that though, what I would do then is in their groups, I would ask them to see if they can agree on where they would place and space. So place just means, so can they put the number in the correct order is what I mean by place here. So so we have an increasing from left to right order, but also the spacing of this. So if numbers are twice as far apart, is that reflected in our number line, and so on. So we want you to make sure that if 2 numbers differ by 1, and that's 1 here, then when they differ by 1 later on, it shouldn't be this much, right? So we want to make sure that that spacing is correct as well. For example, when I've done a fraction number talk, I want kids want to see that the 1/2 is exactly halfway between 0 and 1, and 1/4 is exactly 1/2 between 0 and 1/2, and so on. So that's what I mean by the space part of it. In terms of the routine here, what makes this a routine, again, that predictable nature, is that they have basically 3 moves. One move is to place a remaining number. At this point, if I asked you to place one of the numbers, they'll all be remaining. But the second thing is they can take a number that has been previously placed, and they may decide to nudge that over in one direction or another. So they might choose to space a number that's been put there by a previous group, by another group. And finally, they may also want to create their own card. Sometimes benchmarks come in handy here. And maybe we'll see here in a moment, there might be a benchmark that you might want to create here for this particular set. Okay, so those are kind of the 3 moves that I would ask a volunteer from a group to come up and do here. All right, so I'm going to try to model this one a little bit here. So again, kind of trying to find a way here to make this work within our virtual environment here. I'm going to exit out of the slides. And I'm just going to ask you if I could get one person to volunteer. Again, keep in mind, this would normally be done collaboratively first, but just in the sake of time here, can I get maybe one person to volunteer in terms of placing one of these 6 numbers to get us started on my number line? And this is kind of the low-hanging fruit here. Is there a number that you want to place anywhere along this number line that would help us get started here?
Can you see the chat?
No.
Okay, I'll read.
Sorry, I can't. Never mind. Oh, okay, so perfect. I'll go with Julia to get started here, as saying 0 being right in the middle. So there we go. Putting 0 right in the middle there. And yep. I could take some time as well to talk about why this might be a good choice to get started with here. And noticing that students would notice here that we have both negative and positive numbers in our set. So having 0 is kind of a middle point would make sense here. Also looking at Camille, I noticed that she said the number 10, putting that way over on the right would be a helpful place to get started here. Okay.
We've also got -8 on the far left.
Okay, so I'm going to move that one over here, and then I'm just going to pause for a moment. Okay, so I'm going to stop right there. So right off the bat, we've placed 3 numbers here. Is there anybody that would like to offer a suggestion here? So in this case, this is where we would be calling for volunteers to actually come up, but is there somebody who wants to kind of tell me what to do here?
Jan M has her hand up.
Hi, Chris.
Hi, Jan.
I'm just going to talk about the spacing.
Okay.
Is that okay? So from
Sure.
0 to 10 looks to be about the same spacing as from 0 to -8, and it's not the same amount.
Thanks, Jan. Okay, so that's what I was kind of hoping to lead you there with. And I think I did this kind of purposely when A Younger said on the far left, I made it just as far as 10 was. So a group might come up and decide, you know what, 8's a little bit too far over, maybe right over here, something like that, right? Would be more proportional in terms of where they are. So even though the placement hasn't changed in terms of the order, the spacing between those numbers has. Okay, so that's what I meant by modeling a previously placed number. Any other, what could maybe do next in terms of another move here that I could do?
We do have in the chat from Melissa that
Yep.
8 and -8 would be in the same positions, but on the right and left.
Thanks. Okay, so there we go. And kind of, I don't know if you can see that there. This kind of a little bit of a cheat here, as I got some auto guides that did that for me there. But noticing now that 8 and -8 are equally distant here from 0. Any other thoughts here? So again, your moves are, you could place one of these remaining numbers. You could quibble with how I spaced some of the numbers I had there so far, or you might want to choose to add a new number. Okay, so I just saw a benchmark of 4, and I also saw think about where 5 might be. Okay, so I could use either one of those ideas. Just for speed's sake here, I'm just going to go with, say, the first one that I noticed, which was 5. We could do something similar with 8 as well, and look at, is 5 about? I want to make 5 as a benchmark here, halfway between 0 and 10. Okay, and we could continue through this cycle here. So now seeing this, how do we feel about the placement of 8, and so on. Okay. All right, so I just want to point out with this routine then, those different moods, and I'm just going to place these ones here, speed us up a little bit here. And just notice then that all the different relationships that students will think about here. Okay, so we have 2 is the same space between 8 and 10, but to the right of 0. So yes, this distance between 0 and 2 being the same as the distance between 8 and 10. Also, by the way, the distance between -3 and +2 being the same distance as between 0 and +5. The distance between -3 and +2 being half of the distance between 0 and 10, and so on. So there's lots of different number relationships that you can focus in on here and have conversations with your students about, which is maybe why you probably get a sense of when I said earlier that I've now kind of learned that I want to keep my set of numbers to something smaller, usually around 3 to 4, not the original 6. Plus, we've decided to add an extra number here as well as a benchmark. So just to maybe keep a little bit tighter focus on some of the relationships there. Yes, those numbers were certainly intentional there. The idea of the double distance here of double 5, 8 and 10, 0, 2, all of those were choices that I made when I selected these numbers here. Okay, so hopefully it gives you kind of a sense of the routine. We can kind of riff off of that routine a little bit. I'm going to skip through these slides, but you're welcome to look at them later. And if I could just go back to the slideshow here for a moment. One of the comments that was made in the breakout room that I was in is how much they appreciated seeing Mark model the routine last time. It's certainly one thing to read about or to hear about the resource or a routine from a colleague or online, reading a blog article or a journal article, but actually experiencing it and both as a student from the student side, but also being able to watch to see how it's facilitated is very helpful. So here are some places where you can find some references, some resources for Clothesline Math, both in terms of different card sets like the ones that I created here, as well as kind of an overview of the teacher moves there. And just looking at the chat there, do I give thinking and planning time? Yes, that's exactly what I do here. Sorry if I didn't make that completely clear. But what I would do then is, first of all, collaboratively in groups, students usually on a whiteboard. I've been in classrooms where teachers just have the small little whiteboards there, and the students will just sketch their number line there. And that the nice thing about doing it on a whiteboard is that it's really easy just to erase and to redraw it if they want to nudge those numbers over one direction or another. And yes, when one person comes up to represent the group, then, like I said, they can look over their shoulder or turn to their group and say, like, give them the thumbs up, the thumbs down to see, does what I've just done here, if I was tasked with going up and placing 5 on behalf of my group, did I place it in the same spot as what we have on our clothesline that we have in front of us? Okay, all right. Yeah, and as Mark mentioned here, different representations. So those are included in part of these resources. So what I found, I I'll get to that in a moment here, but just a couple of resources that, again, you can look and peruse these later if you're looking for card sets. Mark mentioned representations here. The other thing that I didn't include in that first little activity that we did with integers was using clothes pegs. So what I might do is, for example, if I were to take the number 8 here, students might look at if you can see at the kind of the top middle of my screen there, we've got double 4 making 8. So students might choose to connect that to the digit 8 just by using a clothespin and so on. What I found as well, I did this in a upper intermediate classroom where students were asked to place 1/2, 1/3, and 1/4, and they placed it as 1/2, and then 1/3 and 1/4. So they had it in an increasing sequence there, as if they were placing 2, 3, and 4. Okay, by giving them a representation, we use little squares where the areas were shaded, and after they matched those pictures to the fractions, the symbolic representation of those fractions, then they were able to revise their thinking. Well, wait a second, our picture, we're showing 1/4 being bigger than 1/2, but actually when we look at the picture, half is shaded and so on, right? So that's one way that we could help with where those multiple representations can help as well. Okay, and this is a routine that can be used from kindergarten through to grade 12. You'll notice the bottom right here, having the X, the 2X, and 3X. It leads to some very interesting conversations, particularly if you place X on the left-hand side of 0, is something that often creates a lot of kind of dissonance for students, because they're thinking that X it's this positive X, so it must be to the right of 0, which isn't necessarily true. So lots of interesting ideas that can come about this at the secondary grades, as well as you can see with the 10 frames here as well, and just looking at place value and that sort of thing at earlier grades. Okay, all right. Always, sometimes, never. Timing wise, I don't think I'm going to be able to give this as much time as I probably would like here. So I'll probably give you a bit of a Cole's notes here. Now, what I might do for this first one here, actually, maybe, you know what, let's go with this. The routine. So the routine is to give students a card or a set of cards. And their task is, again, we're talking about collaborative here, is within their group, can they decide whether this is always true, sometimes true, or never true? Okay, and in the 3 cases there, if it's always true, can they come up with a proof? I'm going to talk briefly a little bit about what it means to prove here in a moment. Is it sometimes true? And this is nice to get students to kind of tinker with numbers and start to look for some exceptions. You know, does it always work for, like, what are some special numbers? Does it work for 0, 1? Does it work for positives, negatives, whole numbers versus fractions? All that types of thing there. So they can start to look for some kind of special cases for the sometimes true. And then the never true, right? Can they, kind of similarly, can they, to approve, can they kind of disprove that? Right? Can they come up with an argument why it can't be true? All right, so if I were actually introducing this one here in my classroom or in a classroom, what I might do instead would it be to ask you to think about 3 numbers, 3 consecutive numbers, to add them, and then maybe to record those sums as kind of an overall as an entire class. Okay, and then maybe stand back and look at, like, what do you notice here? And then kind of act surprised when they say, oh, they all seem to be divisible by 3. Right, so that might be where I'd say, like, is this always true, sometimes true, never true? Okay, so that's kind of the idea here. Okay, but look, assuming in this case that we're just starting off with a card to sort, that would be the activity there. Okay, the idea of proving it or convincing me. Again, just to understand that to prove is a verb. So I think sometimes, particularly at the upper grades, secondary grades, we might think of proof as, you know, the 2-column proofs and that sort of thing. It's more of an object than it is an actual verb, something that students do. to convince their colleagues, or sorry, to convince themselves, their colleagues, or me as a skeptic, right? So, and just one note here about proofs, again, referencing back to Tracy Zager's Becoming the Math Teacher You Wished You'd Had, is that proofs need not be, need not take a symbolic form. It could be words, it could be using algebra, it could be a pictorial proof. So if we look at, if we look at evens and odds, we have this idea of this kind of one little extra bit, and what happens to those little extra bits of the odds when they can be combined? We can convey that just as effectively in pictures as we can with some of this algebraic, expressions of let the first number equal 2k plus 1 and so on, right? So the idea here being we're trying to create a convincing argument. Okay, so in terms of, I mentioned earlier that first one happens to be true. So that would be looking at a proof. How could we prove that a number, that the sum of 3 consecutive numbers is divisible by 3? This one here happens to look at looking for some special cases or ways to break a statement. Okay, so when we divide a whole number by a fraction, the quotient is always greater than the whole number. And initially, with the first set of fractions that students tried, this is likely going to be true. But we want to kind of get at this this habit of, well, what if it was this? What if it were that? That sort of thing, right? So students, I have found with this task here, if they have experience with improper fractions or fractions greater than 1, they start to see that, well, what used to be true, I can now break that with a special set of fractions. So it isn't always true. It's sometimes true depending on a certain condition. Right? Okay, so as a bit of an extension to this as well, sometimes what I've asked kids to do is after they've broken a statement, right? So they've managed to find out that it is sometimes true, not always true. What changes could they make to make this always true? It's another way to extend this activity as well. Timing wise, okay. In terms of creating more of these question prompts or statements, I guess, for students to sort. And by the way, may have missed this or not mentioned this. Similar to the Clothesline Math activity here, I have given these cut out like in little envelopes, or have students cut them out themselves, and then have them draw a 3-column table on their large whiteboards, and have them actually sort and place them as the activity. That becomes the routine. Is again, they're used to creating those always, sometimes never charts, and doing that placement, and as well as that, or in addition to that, being able to justify their thinking, their choice. Why did they choose to place them in a certain column? Okay, so for more examples of this has been crowdsourced. Tracy Zager has collected some different blog posts, as well as people who just sent in examples of statements that you can check out to see if there are some that are applicable for your classroom. Okay. And Sue, did you want to, I can't remember if you were going to jump in now or if you wanted me to do so.
I won't say too much now.
Okay.
Except that we do have one more session. So
Okay.
Wednesday, June 9th, we will send out a link again at 3:30. So 3:30 to 4:30, we're going to do a wrap up. And so we ask that you choose a routine, maybe one of the routines that we introduced today, maybe one of the routines that were introduced in previous sessions, or maybe a routine that we haven't talked about. Try it, find a task, and then try it in your class, and come on back. Meet up, and we'll have more time in our wrap-up session to talk with one another in our small groups, and chat about what have been some of the successes with using these routines, what are some of the challenges, where to next. Like if the BCMT were to do some more work on instructional routines next year, what would you want to see as next steps here? And so I think that's about it for our presentation. And if people have questions, maybe we'll get Chris to stop sharing the screen.
Okay.
And then everyone can, if you want to turn on videos, start to if anyone has any questions, just let us know.
Yeah, and if I missed your question in the chat, if you want to stick around and repeat that, happy to answer that now as well.
May I ask a follow-up to one of my questions?
Yeah.
For the clothesline math, are you rotating through the groups, sending somebody forward, and you just keep moving through it until everybody's satisfied? Or do you give every team one chance so that all cards are placed and then you stop?
So it's a bit of both. So we can call on different students. So when I said like ask for volunteers, that's somewhat true. Also, I may have observed something and kind of given some students a heads up there, like that's an interesting idea. Can you share it when we come together as a whole group? That kind of thing. In terms of like when we're done, one of the things that I've found is that it's kind of obvious as a teacher when groups are just kind of coming up to nudge it over like slightly.
Yeah.
They move, and then you think, okay, we're gonna call because we're kind of within a margin of error here, right? Like, are you really going to come up and move this something that's 60 centimeters apart? Are you going to move it over 1 centimeter or half a centimeter? Because you will get those students that do that. But when it's kind of just having that conversation. Are we fairly confident with the placement here? The other thing that I didn't mention is because I'm actually using that physical string, I've used that then to actually do the test. Like, do they want me to test? Are they ready now for me to test some of those relationships that I mentioned? So you can kind of take the slack, and I might measure off the distance. I won't go too far because I'll be off. But let's say the distance between 0 and 10 is this. I can actually use the slack and measure that, the distance between the two cards, or between the centers of the two cards, and then slide that over and see if it applies to the other places where there's also a distance of 10. You can do something similar with the 1/2 as well, right? Where just folding it in half. So, and we usually get to the point where, as a class, we're fairly confident. Like I might be off by a pinky or something like that, but we weren't going to spend the time and effort to kind of nudge it to be that precise.
Totally, that makes sense. Right. Awesome, thank you.
Yeah, you're welcome. Any other questions here?
There was a question about links for the recordings from the previous sessions, and I'm not really sure. Like when we send out the link to the recording for this session, I'm not sure if it will just take them to where this session is recorded or where all of them are recorded.
Yeah, so and like you said, that is being worked at, by Colin and we talked about having that on the website as well. So for Jan here, Marker, I think send her that link directly. Insert here.
Send a link to the YouTube channel, and then this one, it'll take a couple of days before it's there. But if they want access to the other sessions, they'll be able to see them there. So I can go find that link and paste it in.
Okay. Okay.
Oh, I can stop recording now.